So we'll move on to the next topic, that is security at transport layer. So up to this point I was explaining you and I made you guys understand about the significance of authentication, significance of the encryption, decryption, and we have also discussed about couple of encrypting and decrypting algorithms, how to generate the key and how the authentication could be done. And we have also discussed about Diffie-Hellman key exchange, how the key could get exchanged across the network very much securely, and that in turn how can help us out in generating a private key or a session key for further conversation. So when we have already discussed all these things, the next question or the next important thing is where to deploy whatever we have understood till now. Okay, so we are done with the security concepts. We are done with the authentication concepts. We know the types of attacks, how to get rid of them, how to prevent them, or how to avoid them. If at all if it has been attacked, then what countermeasures that we are supposed to take. We have enough knowledge about all the requirements and how the things can get placed in their respective places. Okay, and also we have understood the importance or the need of the security. So when we have done with all these concepts, next comes the question where to deploy this security concepts that we have understood till now. Okay, so even this we had discussed in the previous class itself, in the OSL layer, where to place the security concepts, whether should I provide the security to each and individual application, should I come out with security with each and every applications, or let us just make the deployment of security at one place and let the all applications be what get the benefit of it. That is what we discussed in the previous class, when we somewhere we understood how exactly the security concepts that we studied gets deployed across the network, how it will be utilized, how the renewals take place, and how where exactly it will be deployed. So once we have understood even that concept, now we'll move on to the next level of it, and we'll just try to understand one of the applications or one of the protocol. Okay, in particular, that is the security at transport layer. The security at transport layer here will be concentrating on one of the protocol, that is secure socket layer protocol, SSL. So in the previous chapter and before to that, I kept on saying about SSL, but I never stressed anything, or even I didn't even give you the full form of SSL. The only reason was because we have things to discuss in detail in this chapter, that is the secure what the security at transport layer. Okay, so coming to this chapter, so in this chapter you will be studying about this secure socket layer protocol in detail. So what is it, where it is being deployed, how exactly it will work, all these things will be discussing in detail. So coming to this SSL, it was emerged in the year 1994 by this Netscape people were the one who developed it, and this protocol, it is a principal means of securing communication between a internet client, I mean to say the browser, and a server. Okay, so this SSL, it is sandwiched between the TCP and an application layer protocol. Okay, so TCP and the application layer protocol, in between this secure socket layer protocol has been placed. Okay, that's the reason why we use the word sandwiched. Okay, so later after 19 I mean to say in the year 1999, this IETF, one of the standardized committee, so these people, they standardized it and they called it as transport layer security. So you can either call it as interchangeably, you can either refer to it as SSL or TLS. Both are one and the same, but this TLS is a standardized format of SSL. Okay, this is a very much brief introduction about SSL. To know about it in in detail, So as I already mentioned, SSL, it is actually sandwiched between the TCP and then application layer protocol. Okay, and this application like this protocol, it is independent, and this protocols such as HTTP, FTP, SMTP, IMAP, POP can all be run over SSL. Okay, and how they can be run, or application protocols secured by SSL are usually suffixed by yes. So any application, I mean to say this HTTP, FTP, SMTP, so if they are secured by SSL, I mean to say if they have this protocol application within it, so in that case they'll have the suffix s. Okay, HTTPS, FTPS, SMTPS. So all these easily you can just make a note that they are being secured by SSL. Okay, so the normal HTTP, it runs in the port 80 by the normal HTTP, it run on port 80, whereas HTTPS, it runs on port 443. Okay, so if you can remember in your CN lab, one of the experiment, you have FTP to work with, if I remember. So in that you will be asked to get into the port number 21, so mention the port number as 21. So if you are working with FTPS, so then you have to run it on port 990. Okay, so what this SSL actually, the secure socket layer, this is comprised of two main protocol. One is handshake protocol and record layer protocol. So to just brief what is this handshake protocol and what is this record layer protocol is. So this handshake protocol, it has got few responsibilities. So the responsibilities are something like this. It will actually negotiate the set of algorithms that are supposed to be used for securing the communication link. So when it comes to the communication link, so what algorithm should I make use of for the purpose of security? So that will be negotiated by this handshake protocol. Negotiating is when two people wants to communicate, they want the communication to get established, if I'm not wrong. Okay, so those people have to come to a conclusion that what algorithms they'll be relying on. So that will be taken care by this handshake protocol. Okay, so this handshake protocol, it negotiates a set of algorithms to be used for securing the communication link. Okay, first responsibility of handshake protocol. The second one is, it will also include the algorithms for encryption and hash computation. Okay, so the I mean to say the responsibility to make it in general. So this handshake protocol will take care of the secure algorithms that they have to come into conclusion. Okay, and what keys, which encrypting algorithms they rely on, how the key should get exchanged, all these things, and along with that, this handshake protocol will also is also worried about the server authentication. Server authentication in SSL is mandatory, and it is performed at as a part of handshake. Okay, and the handshake protocol is also responsible for deriving keys for encryption and MAC computation, as I already mentioned. So this handshake protocol, it will take care of the key exchange, the keys that has to be generated for encryption and decryption purpose, and it also worried about hash computation, MAC computation, message authentication code, the hash computation, and also it will and one of the added responsibility, or it is the mandatory thing, is the server authentication is mandatory, and it is done at the handshake protocol, and it is the responsibility of handshake protocol. So then next question is, what is the responsibility of record layer protocol? So to just brief it up, message message authentication, integrity checking, and encryption. So these three. Okay, message, I'll repeat: message authentication, integrity, and encryption. All these three is performed by the SSL record layer protocol. Actually this protocol I mean to say the record layer protocol. This record layer protocol, it sits just below the handshake protocol, and it protects each message that is exchanged by two communicating parties. Okay, so this record layer protocol, it sits just below the handshake protocol, and it will protect each message that get exchanged by two communicating parties. Okay, and along with this, the record layer protocol also detects replayed, reordered and duplicate packets. This is just a brief introduction about these two protocol. Actually, this SSL is comprised of these two. I mean to say the responsibility of SSL, it has been divided among these two. So handshake protocol, here they'll come to the conclusion that yes, these algorithms will be using for the purpose of MAC computation, hash computation, encryption, key exchange, for all in terms of security for the communication link. Okay, so what happens in the record layer protocol, all this key that got generated here, all the hash computation that's supposed to be performed, all these things will be done by this record layer protocol. And there comes any message that get exchanged between the two, it will be encrypted or it will be secured by the record layer protocol. So that is how the things are being exchanged between those two. The same thing, it has been put up here also, and also you can just see in this figure the SSL on protocol stack. So the SSL handshake, alert protocol, record layer protocol, you can just see this record layer protocol is just below this. Okay, so in the application you can find all this HTTP, FTP, SMTP, IMAP, POP, all this comes in the application layer. So what is this chain cipher specification, I'll tell you. Okay, and this record layer protocol, TCP, you can just see between this TCP and application you can find this SSL handshake. Whatever I explained just now, I'm just repeating it by depicting that in the figure. Okay, see this SSL, it has been sandwiched between TCP and application layer protocols. Okay, and this SSL, it is not a single protocol, instead it is comprised of two protocols, SSL handshake and SSL record layer. So SSL handshake comes first, and just below this you can find the record layer protocol. Okay, so next that whatever I explained now about the handshake protocol and SSL record layer protocol, that is I have just type the same in this slide. You can just find the same content in this slide. So next, to discuss in detail about handshake protocol, so there I just introduced what is handshake protocol. Now I'll be explaining you things in detail. Okay, so what happens exactly when it comes to handshake protocol? So we have some 4 steps that actually happens in this handshake protocol. Again here, the client initially, so we'll have this client and server. So initially the client initiates the handshake with the server. So he might go with a new session, he might start a new session, or he might resume an existing session, or he might establish a new session with an existing session. So any of these 3 types, you as a client you can just mention. Okay, if you are communicating with that person for the first time, you can go for you can just start a new session. So if you have terminated if you have terminated the session in between, so in that case you can just resume it, or the possibilities of the communication link. Okay, so we have 3 types, and we have some steps as I mentioned already when it comes to a handshake. So first we'll go with an agreement on common cipher suit. Next will the receipt and validation of server certificate takes place, and next the communication of pre-master secret takes place, and next the integrity verification of handshake messages and server authentication. So these are the steps which actually happens when it comes to handshake. Okay, so as I already mentioned, so first we'll be negotiating on the secure algorithms. Okay, that is what is mentioned here, common server suit. So once we have done with that, for the communication purpose we need a certificate. Okay, because the public key encryption, initial encryption has to take place using the public and private keys with the level of certificate issuer, that is certificate authority. So that recipient and validation of say server certificate takes place. Next will be exchanging the pre-master secret, that is once after the validation of the certificate and all it is done. So next definitely we'll try to generate a secret key, and will exchange that secret key. So and computation of derived secrets, pre-master secret. And next the integrity verification. So once after this secret key generation and all, definitely will also associate MAC, that is message authentication code, or a hash computation takes place, and this will be the responsibility, or this will be done for the purpose of integrity verifying purpose. Okay, and finally the server authentication. So what exactly happens in each and every steps, we'll try to understand that in detail. Okay, so in the first step the two messages are communicated in this step, that is client hello and server hello. So this client hello and server hello. So what exactly happens here is, so first thing is, in this step 1, should a new session be established, okay, or the existing session should be resumed, or a new session in the existing one has to be established. That is what we'll be discussing here. So in the former case, I mean to say, when a new session wants to get established, the session ID field in client hello, okay, is 0, else the field is set to the ID of the session to be reused. So we'll have a session ID in this client hello. So it will be set to 0 if you are establishing a new session, or else it will be set to the session ID of the existing one. Okay, that will say whether to resume the existing one. The session ID field in the server hello message is the ID of the new session to be established, or the ID of an existing one. Okay, so in turn again it will send the session ID for if you are asking to resume the existing session, or else whether to go with a new session. Okay, so next is the algorithm to be used in computing the MAC, okay, for message integrity, and permissible choice include MD5 or SHA1, whether to go with MD5 or SHA1 for MAC computation, and whether or not message confidentiality is required. It is up to you whether to go with along with integrity, whether you are concerned about the confidentiality as well. If you are concerned about confidentiality, so what encryption algorithm to rely on, whether it is DES or 3DES, AES, RC4, etc., like this. Okay, and also you will be deciding about the key exchange method used for communicating the pre-master secret. Okay, so these are the things. And in addition to agreeing and cipher suit, both sides choose an exchange to, and they also exchange 32 byte nouns RA and RP in this step. So in the server hello, sorry, this client hello and server hello, this step what I was speaking about. So here as I mentioned, so here we'll be what first we'll be deciding whether a new session to get established, or to resume a existing one, and that you can just get to know by the session ID, whether it has been mentioned as 0 or the existing session ID value has been mentioned. Okay, and the second one is to decide on the MAC, the message integrity. Okay, so if you are generating a MAC, which one will you make use of, whether you will rely on SHA1 or MD5, or and also if you are concerned about confidentiality, then which algorithm do you wish to go with, DES, 3DES, AES, RC4, like this. And also you will be deciding on the key exchange method. So for the pre-master secret, along with this you will also add with the challenge response protocol will also be used here. So here you will be generating a a random number which is of 32 byte random number will be generated, and that is RA and RB, or RC or RS, whatever you want, you can just mention it. Okay, So next is what is this step 2. So steps in the step 2, the server will communicate its certificate to the client. So on receiving this certificate, the client checks the owner's name, URL and validity period, and it also verifies the signature of the certificate authority on the certificate. So on successful verification of all these fields, so that will guarantee the authenticity of the sender, that is a server certificate. Okay, so the server certificate is repeatedly transmitted over the network in the clear and can be easily obtained. Okay, so again the authentication of server only occurs at the end of step 4. So the authentication that we'll see later, but any of the server certificate content will be verified by the client. Okay, so once after verification, next comes this next step 3. So in the step 3, the client choose a pre-master secret, and this pre-master secret, as I mentioned, it is a 48 byte random number. Okay, so this secret is encrypted with the server's public key. Okay, so any of the server has shared its certificate, and its certificates contain public key. So this pre-master secret, that is 48 byte random number, so that is encrypted using server's public key, and it is sent to the server in this client key exchange message. Okay, so thereafter both the client and server, they'll compute the master secret. So on receiving this what pre-master secret, so both this client and server will be what generating a master secret. They'll be computing a master secret. So this is an HMAC style function. So two nouns will be exchanged, and that will actually used, see, RA and RB, what I spoke before, those are for their what to avoid the replay attack. Okay, so now whatever the random number that got generated, so that what you will be used to generate the master secret. Okay, so you can just see the master secret, it has been generated by pre-master secret, that is 48 byte random number, and RA and RB 32 byte random number that was actually exchanged between them, and also few predefined constants will be there, and when those constants will be used, and the master key will be generated. Okay, so what exactly is derived from this master key later is initialization vector for encrypting messages for client to server, initialization for encrypting messages from server to client, secret key for encrypting messages from client to server, secret key for encrypting messages from server to client, secret for computing keyed hash on messages from client to server, and secret for computing key hashed on messages from server to client. So all these are been derived from this one master secret. Okay, where exactly or how exactly this master secret key will be used is for all these purposes. Okay, and finally we have step 4. So this step, it involves the exchange of two messages in each direction. So the first of is change cipher specification. Okay, so that message, so you can just see here, change cipher spec. Okay, specification, in short it has been mentioned as spec. So the party that sends this message signals that from now on the cipher suit just negotiated and the key just computed will be used. So whatever the all the negotiation has been done, and this whatever the master secret key just now what got exchanged will be used further for what communication. Okay, and the second message is in this step is finished message. You can just see the finished message here, the finished message. So this message includes a key hash on the concatenation of all handshake messages sent in proceedings plus a predefined constant. Okay, so this key, the hash serves as integrity check on previous handshake messages. Okay, so after the server receives this change cipher spec and finished message from the client, it will verify the computation of keyed hash. It then computes its own keyed hash that covers the previous handshake message plus predefined constant, which is distinct from the one used by the client. Okay, the client receives the keyed hash and verifies it. Only at this point is the server authentication to the client. Okay, so this is where the server authentication will be done. So once after these two messages received, and again the hash computation takes place here, and it will get to know, okay, the integrity check is done and also the message is sent by the server. So after this, the server authentication is completed. Okay, so this is how the SSL handshake works. So in the next video I'll be explaining you about record layer protocol. Okay.